Alright everyone, today we're going to be talking about angles and their measures just like we did in 5.1a. However, today we're going to be talking about radians. Let's start out with the bell work and we'll talk about what radians are. So the bell work said, are the angles negative 128 and 1312 coterminal? The correct answer is yes. Yes, they are. And the way we could check that is we could pick either one of those angles to start off with. I'm going to pick negative 128. Let me go back to black. All right, negative 128 degrees. That's going to equal 1312 plus k times 360, because coterminal really means are they 360 degrees away from each other. It might not be exactly 360. It might be two 360s, three 360s, anything like that. What we're trying to do is we're trying to check to see if k is an integer. So we'd work our way down and solve this, and you would, after doing some math yoga, you should come up with k equals 4. Since k is 4, 4 is an integer. It is in fact coterminal. In other words, since k is 4, that means there are 4 360s between negative 128 and 1312. If you take your calculator and type in negative 128 and you add 360, add 360, add 360, and add 360 one more time, you'd come up with 1312. So that means they are in fact coterminal. They would not be coterminal if k was a decimal. All right, so like I said, we're talking about radians, which is kind of a brand new thing to us. The definition is angle formed when a central angle theta intercepts an arc the same length as the radius of the circle. Greek letters are commonly used in trig to represent angle measures. What's actually happening here is a radian. A radian is based upon our radius. The length of our radius, so if we look down at that circle, that length of our radius right here, if we had applied that to that circle, that would actually be 1 radian in length. So 1 radian is your radius stretched along your circumference. And just the way that works, this is really nice. There are exactly 2 pi radians in every circle. And pi radians in half the circle. You have to learn this and you have to remember this. In short, if you don't want to remember what the radius is and what a radian is on a whole, what you do need to recognize is a radian is another measurement of degrees. It's kind of like degrees. I guess a good way to look at it is it's feet and meters. It's 2 different ways to measure the same thing. We use radians primarily in pre-calculus rather than degrees. So the big starting off point is the fact that 2 pi is going to equal 360 degrees. Or in other words, pi actually equals 180 degrees. We need to know this when we convert it. We need to know we're going to picture it, but just know that in the future, we're going to rely more on our radians than we are our degrees. So the quicker you get accustomed to these, the easier this class will be. Moving on, converting between radians and degrees. We're going to use dimensional analysis, like converting feet to inches, to convert between decimal degrees and radians. In effect, when we switch between feet and inches, our goal is to multiply by fractions that cancel out feet and give us inches in the end. What that's going to look like? Well, we're going to either use pi over 180 or we're going to use 180 degrees over pi to convert the two. And this is exactly what we're thinking of. So we're starting with 415 degrees. With dimensional analysis, what we're really thinking about is a fraction. So in my head, I'm actually picturing 415 degrees over 1. Now we need to multiply that something in the conversion. Well, in order for our degrees to cancel out, we need to have degrees on the bottom, because a degree divided by a degree, the degrees will cancel out. Excuse me. Which means we are definitely going to use that pi over 180 for this to work. So we're going to put 180, and we'll put pi on top. Well, when you're multiplying, you go straight across. Our degrees will actually cancel out. And we'll be left with 415 pi over 180, which is actually going to simplify down to 83 pi over 36. And we're going to leave it in that form. Generally speaking, radians have something that's not a decimal, so like a fraction, and you usually have pi in it as well. That's how you're going to know it's in radians. Another way you're going to know it's radians, there's going to be no degree symbol. If there's no degree symbol, it is radians. Usually you have a pi, but there are times where you do not, and you just have to make sure there's no degree symbol and you are in radians. All right, negative 125 degrees. Once again, we're thinking, well, I'm going to picture that as a fraction. To get rid of degrees, I'm going to put degrees down there. We know 180 degrees equals pi. So pi over 180 is actually multiplying by 1. You're allowed to multiply things by 1. Our degrees would cancel out. And we will multiply straight across. And that would equal negative 125 pi divided by 180. Once again, we're going to simplify the fraction down to negative 25 pi over 36. If you're kind of slow or it takes a while to reduce these fractions, worry more about getting that negative 125 pi over 180, especially on a test, because if it's taking a whole bunch of time to simplify things, I'd rather have this answer than you take 10 minutes to give me that answer. All right, let's go the other direction. We are now going to go from radians to degrees. Once again, we're picturing fractions. Well, these are already in fraction form, so that's going to help us out. When we're dealing with radians, I don't want my answer to have pi in it, usually. If it does have pi, we're going to approximate it using our calculator. So what I'm thinking about is, well, I need to cancel out that pi. This is really saying, in our head, it's 14 pi radians. That's what we should be thinking in our head. So that means on the bottom I need to have radians, which the only one that works with radians is that pi. Radians. And then we're going to put 180 degrees on top. Another way to think about dimensional analysis, what we want to come out, we're going to put on the top when we're talking about degrees or radians. So I want degrees out, so I'm going to put that 180 degrees on top. Once again, our radians would cancel out just like our degrees did, and so will our pi. And we're just going to be left with 14 over 9 times 180, which is going to equal 280 degrees. There is another way to do this. There's another way to do this in the fact that we know pi equals 180 degrees. So to convert from radians to degrees, if there's a pi in it, you can simply replace the pi with 180. So rather than writing 14 pi, we're going to write 14 times 180 divided by 9, which just so happens to equal 280 degrees. Choose your method. I would like you to know how to do the top method, but know that the bottom method is a nice little shortcut if there's pi in it. All right, our next one, we have 3 pi over 8 times. This time, I'm just going to put pi on the bottom. We just, in our head, are going to know that radians are canceling out. And we'll have not 360, but we're going to have 180, because 180 equals pi. Our pi's would cancel out. We'd multiply straight across. And when you're doing it in degrees, we're going to round it, or we're going to take it to the decimal. In this case, we could plug in our calculator and come up with 67.5 degrees. For radians, we leave it in fraction form, like that 83 pi over 36. For degrees, we're just going to put the decimals down, because it is decimal degrees. Remember that from yesterday? It's decimal degrees, so we want decimals. Here's the weird one. We have -6. If you just have a number and I tell you it's an angle, you have to ask yourself, is there a degree symbol? There is not a degree symbol. So that means it has to be radians. If it's radians, you have to put the pi on the bottom. So we're really thinking that's 6 radians. And we're going to multiply that by 180 degrees. over pi. Remember, we're really thinking radians when we're writing it. Radians will cancel out, but in this case, there's no pi to cancel out. So what we're going to do is we're going to throw this whole thing in our calculator. We're going to type in -6 times 180, and we're going to divide it by pi. And we are going to get an approximation, and we're going to get the approximation of -343.78 degrees. And that is now converting between radians to degrees and, degrees to radians. All right, this part's a little more tricky than it is with degrees, considering we're not familiar with radians. And that is determining in which quadrant an angle lies using radians. Our first step is, well, we know we have an initial side. We know we have an initial side, and we know it's positive, so we know it's going somewhere in that direction. We just don't know how far. The first thing we're going to do is, if you remember yesterday, we labeled our x and y axes, the tops, bottoms, left, right. We labeled it with 0, 90, 180, 270. We kind of judged where, say, 240 degrees was. We knew it was between that 180 and 270. We're going to do the same thing with radians. We're going to start with 0 radians. Notice I'm not putting any degree symbol because it's radians. The two things we know for sure, is 180 degrees is pi. 360 is 2 pi. Well, this space right up here is halfway between 0 and pi. Well, halfway between 0 and pi would be pi over 2. All right, then the space down here is between pi and 2 pi. Well, whenever you're finding an average of something, you add the 2 and divide by 2. So that's going to be 3 pi over 2. The other way you could have did that math is you could have just taken pi and added pi over 2 to it, and you would have came up with 3 pi over 2. It's a good idea to know these major measurements, the 0, pi over 2, pi, 3 pi over 2, and 2 pi. It'll be a nice starting off point if you can get that down. Now, here's the problem. If you're not great with fractions and you're not great at knowing where 7 over 5 is compared to 3 over 2, one of the easiest ways to do this is just use your calculator. Just use your calculator to say, okay, 3 pi over 2. If I take 3 divided by 2, I'm really talking about 1.5 pi. Now, normally don't write this on the circle, but if it helps you, you can. And we're also thinking like pi over 2 is really decimal form would be 0.5 pi. And this would be our 1 pi. All right, 7 pi over 5. Well, I'm really thinking about, in my calculator, I'm just going to type in 7 over 5 pi, which is going to equal 1.4 pi. So now I'm asking myself, where is 1.4 on this circle? Well, 1.4 is going to be somewhere about here. And so we're talking about quadrant 3. All right, let's do the same thing up here. Note it's negative, so we're going to go in the negative direction. So we're going to have 0. Rather than pi, we're going to have negative pi. And down here is actually going to be our negative pi over 2. And up here is going to be our negative 3 pi over 2. Once again, we could turn things into decimals. What I'm looking at, just to shortcut this, is I know that this pi over 2 is 1/2 pi. That's 0.5 pi. Well, 1 over 12 is a lot smaller than 1/2. So without labeling everything, I know that it's less than 1/2, so it's going to look something like that. That is our negative pi over 12. That is 1/12 of pi. 1/12 is smaller than 1/2, so I know exactly what quadrant it is in. It is in quadrant 4. All right, the final one says 2.25. Uh-oh, we don't have pi. We don't have pi. So what we're going to do is we're going to translate things into not having pi. So we're going to approximate things. So that's 2.25. So remember how we had pi over 2 up here? well, let's write them all down. 0 pi over 2 pi, 3 pi over 2, 2 pi. Well, since this doesn't have pi in it, I'm going to approximate all of these by plugging in my calculator. So I'm going to type in pi over 2 in my calculator, and that's going to come out to about 1.57. Pi itself is about 3.14. That's as far as I need to go. 2.25 is somewhere between 1.57 and 3.14. So we're talking about something that looks like this. And we are in quadrant 2. I don't recommend this as it takes a long time, but you can if you want to. We know how to convert radians to degrees. So you could have turned all of these into degrees and went from there. And remember, changing them to degrees would just be simply 7 pi over 5, change the pi for 180, 7 times 180 divided by 5. So you could have converted all these to degrees. It seems easier now, but in the future, you're going to want to just be able to know this stuff and see fractions a lot easier. So I do not recommend doing it. It is possible, though. All right, coterminal angles. Reminder, coterminal angles is one that is just multiple of full turns from the original, and a full turn in radians is 2 pi. In other words, when I told you about coterminal angles yesterday, I kept stressing 360. I kept saying it's either adding or subtracting multiples of 360. Well, we're not using 360 degrees. Instead, we're using 2 pi because 2 pi equals 360 degrees. So in radians with coterminal angles, you're thinking about, can I add 2 pi over and over and over to get to the other angle? Or can I subtract 2 pi over and over to get to my angle? Well, the formula is going to look just like the one we did yesterday. It's going to look something like, if I have two angles in standard position, they're coterminal if and only if one angle, let's call it beta, is going to equal the other angle, alpha, plus, now yesterday we said it was k times 360. We don't have 360 this time, we have k times 2 pi. So we're just adding or subtracting 2 pi, which is our 360 equivalent. Right here it says find two positive and one negative angle that are coterminal with pi over 6. So to come up with a positive angle, all we're going to do is we're going to take pi over 6 and we are going to add 2 pi. Now I want to test if I'm not sure how to add those two things together, which we should. It's an algebra 2 thing, but at the very least leave it as that. But we're going to go further. We're going to say, okay, to add two things together with fractions, they have to have a common denominator. So I'm going to leave the pi over 6, but I want that 2 pi to have a 6 on the bottom, which means I'm really going to multiply it by 6 over 6. So what I'm doing is I'm multiplying this by 6 over 6 to give me 12 pi over 6, which is going to equal 13 pi over 6. All right, a way to get my next positive angle is take pi over 6, and I'm going to add 2 pi's, which is actually going pi over 6 plus 4 pi. Alternatively, you could have just added 2 pi to that answer up there. That would have got you the same answer. All right, so once again, I need to have a common denominator in order to add them. So once again, I'm looking for 6 to be a common denominator, so I'm going to take 6 over 6 and I'll multiply it by that. That will give me pi over 6 plus 6 times 4 is going to be 24 pi over 6, which is going to equal 25 pi over 6. To get a negative one, we're just going to go pi over 6 minus 2 pi. That's going to be pi over 6 minus 12 pi over 6. I got that from up here. Already did the math, so let's not redo it. That's going to end up with being a negative 11 pi over 6. Coterminal, add 2 pi or subtract 2 pi over and over and over, and you can't go wrong. All right, that officially is the end of what radians are. However, we are going to apply what we learned to our unit circle. So very quickly, we're going to talk about degrees. I'm going to put the degrees on the inside because I find them less important than radians at this stage. So remember, we start with 0 degrees. I always go 30, 60, 90, 120, 150, 180, 210. Let me scroll down. 240 and 270, 300, and then I do 330. All right, then I just add 15 on the inside. Remember, these were just, I add 30 over and over and over. Now we're going to go to the inside, which means I just add 15. So I have 30 plus 15 is 45 degrees. I have 120 plus 15 is 135 degrees. 210 plus 15 is 225 degrees. And finally, we have our 300 plus 15, which is 315 degrees. For radians, you need to just kind of have the 4 big ones memorized. And that is our 0 radians, our pi over 2 radians, our pi radians, and finally our 3 pi over 2 radians. I don't grade you on this, but you should know that 2 pi is 360 degrees. All right. So I'm going to go ahead and put the 360 in here as well. Not necessary, but I like to do it just because we should know it, and it's good to write down. All right. Now these inside ones. The worst possible way you can do this is actually convert the degrees to radians. That's going to take an enormous amount of time, and I will not give you enough time to do that. So here is one method to do it. There are multiple ways to memorize it. You can just straight up memorize it. Whatever you need to do, I'm just going to show you the way that works for me. And that is to remember the 3 major radian bases. So just bear with me for a second as I write some information down. So our radian bases. Our radians only have 3 possible bases besides that, the ones that I've already had up here, the 2, like pi over 2 and 3 pi over 2. We're talking about all the other ones. They'll either have a base of 3, a base of 4, or a base of 6, because the rest are going to be fractions. All right, now what we're going to do, and this is kind of some scratch work, I'm going to put all those bases down. So I'm going to put a fraction with 3 on it, and I made that line purposely long. You're going to want it long. And then I'm going to put 4 on the bottom of a fraction. And then finally I'm going to put a 6 on the bottom of a fraction. Every one of these, you're going to start out by putting a 1. 1, 1. All right, the first one is easiest. We start at 1, and we're going to put 4 numbers on top. All of these are going to have 4 numbers on top. So I'm going to go 1, 2, then we go 3. I'm counting the bottom is my 3, and then we come up to 4, 5. Notice I have 4 numbers on top. I got 1, 2, 4, 5. So it goes 1, 2, 3 on the bottom, 4, 5. So I have 1, 2, 4, 5 on top. Those are all the fractions we're going to need with 3 on the bottom. Now we're going to go to our 4. It's similar but slightly different. We're going to go 1, and we're going to skip to 3. Because what I want this to look like is I want it to go 1, 3, 4, 5. So it's going to go 1, 3, 4, 5. And notice I had to skip a number here, so I'm actually adding 2. So I'm going to add 2 here as well to get me to 7. So it goes 1, 3, 4, 5, 7. We're going to follow that exact same thing with the 6. I'm going to go 1, and then I want the middle ones to be all 1 away. So it's going to go 5, 6, 7. Now I'm going to count how many I had to skip to get to that 5. That's plus 4, so we're going to add 4 here. And we are going to be at 11. Those are every fraction you need for the rest of the unit circle. And how we're going to do this. Well, look at your 30 degrees. Your 30 degrees is going to start with your 1s. All right, we're going to start with our 1s in our first quadrant. The smallest number is 1 over 6. 1 over 4 is slightly bigger. 1 over 3 is the biggest. So what we're thinking about is we're thinking about going 1, over 6. That's going to be followed by 1 over 4. And it's going to be followed by 1 over 3. The only thing I need to add to this now is pi. So in fact, you don't actually need the ones. You just need pi over 6, pi over 4, pi over 3. All right, now we went to 3. So you can kind of see this. It goes 6, 4, 3, 2. And then we're going to count up. We're going to go 3, 4, 6. And I'm actually going to continue that all the way around. At 210, I'm going to count down at 6, 4, 3. And finally, I'm going to come up with 3, 4, 6. And now we're just going to put in order how they appear. So if we look at 3, we already used 1 up over here. So we're going to move on to our 2. So this is going to be 2 pi over 3. The next number in 4 is going to be that 3 that I just circled. So we're going to have 3 pi over 4. Our next number with 6 would be that 5. So we're going to have 5 pi over 6. Now we're sticking with 6 and we're moving on to that 7 pi over 6. We're on that third number for 4, so that's 5 pi over 4. And finally, we're on that third number for 3, which is 4 pi over 3. Moving on with 3, our last number up there is 5, so it's 5 pi over 3. For our 4, it's 7 pi over 3. And finally, for 6, it's 11 pi over 3. Now, there's multiple ways to do this. I find this to be the easiest way. You need to find a way that you can do quickly, because I will time you on being able to write this down as quickly as possible. All right, everybody, have a wonderful day.